In this first part of 2.1, we're going to be talking about different types of relations and functions and kind of defining the different categories and explaining what the difference between them are. So there's this little area right here. We're going to define 3 different types of functions, or I guess really 2. You can be one-to-one, you can be on-to, or you can combine them and you can be both. So you should have this written in your vocabulary, but what it means to be one-to-one means that each element of the domain goes to exactly one unique element of the range. So that's what you should have in your vocabulary. Let me show you what that looks like. So let's do domain and range. Let's say we've got 1, 2, and 3. Those are elements of our domain. And then let's do A, B, C, and D as elements of our range. Okay, so here's how the mapping is going to go. Let's say 1 gets mapped to D, 2 gets mapped to B, and 3 gets mapped to A. So this is a one-to-one function. It has nothing to do with the fact that the C is missing. What's important here is that A only got mapped by the 3, and B only got mapped by the 2, and D only got mapped by the 1. So one-to-one means everyone in the domain only gets paired with one element in the range, and each of the elements in the range only came from one element in the domain. Because remember, it is possible that like 1 could map to D and 2 could map to D, but that wouldn't be one-to-one. Okay, next category is onto. What onto means that each element of the range is mapped from some sort of element in the domain. So let's do something slightly different here. Let's say 1, 2, 3, 4. And then for range, we'll just do ABC. Okay, so say this is the mapping. Let's say 1 goes to A, 2 goes to B, let's say 3 also goes to B, and 4 goes to C. Okay, so what it means to be onto is that everything in the range got hit. A, B, and C got hit by different elements of the domain. Okay, so let's compare and contrast these real quick. This picture right here is not onto because the C did not get hit. So every element of the range did not get hit. This one is not one-to-one because the B gets hit twice. So this one's one-to-one because each one only gets hit a maximum of 1 time, and this one's onto because they all get hit. All right? Now both means they all get hit exactly 1 time. They all get hit, that's what makes it onto, but they each only get hit once, and that's what makes it one-to-one. So let's do something like this, 1, 2, 3. And then the way the pairing works out, that doesn't matter. So like let's say 1 goes to B, and 2 goes to C, and 3 goes to A. So again, this is one-to-one, because there's only a one-to-one pairing here. These only got matched by 1, not 2. And then onto means every single one of them got hit by an element of the domain. So that's what those 3 definitions mean. Let's see which we've got covered here. So for both of these, we want to state the domain and range. And remember, domain is all the possible x values, range is all the possible y values. So let's start with that. So this is a set of ordered pairs. So let's start with the domain. Domain is all of the x values that get hit. So I'm just going to move from left to right. So like this is the first one, and this is an x value of -1, 2, 3. So -3 gets hit. These points are both at -2 for an x value. This point's at -1. This point right here is at 0. This point is at 1, and then we have 3, and then 4. So those are all our possible x values. So if you were to look at the coordinate points, I just listed all the different x values. But remember, you don't list them twice. And then range is my y value. So this is my lowest y value, and that's a -3. These are both at a -2. These are both at 1. These are both at 2, and then this one's at 4. Okay, so those are all the possible y values that were covered. Then determine whether each relation is a function. So remember what it means to be a function. Now this is super, super important. What it means to be a function is that each element in the domain only goes to one element in the range. So we've got a couple of little issues here. This set of points is an issue because our x value is -2 and it's getting mapped to 2 different values. That can't happen. So this is not a function. Now you may be wondering if these 2 points are okay because they have the same y value, or these two, and that's actually fine. Here's an example I want you to keep in mind. Say that I went all the way around the room and I got all of your heights. It's definitely possible that 2 of you could have the same height. That's what's happening here. 2 different x values have the same height or y value. Same thing here, same thing here. But this is basically the same as saying that one person has 2 different heights. That's not a thing. That's not possible. One person only has 1 height, but it is possible that 2 people have the same height. So that's the difference here. These are like the people, and these are like the heights. So each person only has 1 height, but it's possible that 2 people get mapped to the same height. So that's what it means to be a function. These points right here are the reason why this is not a function. And then if it is a function, answer a further question. Since it's not a function, we're not going to answer that last question. Okay, now domain and range. We don't need to state the domain and range again. The domain are these 5 values right here, and the range are these 5 values right here. Let's talk about the function thing. So all of these x values, see how they all only go to 1 value of the range? So it's like each person having their own unique height. So this is a function. And then because it's a function, now we can answer this question. So let's determine if it's 1-to-1. So does each value in the range only get hit once? Yes, 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 no. The 6 gets hit twice. So it is not 1-to-1. Now let's see if it's onto. Onto means every single value gets hit at least once. Yes, 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 no. The 8 doesn't get hit. So because the 6 gets hit twice, it's not 1-to-1, and because the 8 doesn't get hit at all, it's not onto. So this is actually neither. Okay, let's look at the next example that we have. This is going to describe the vertical line test, and the vertical line test helps us to figure out whether something is or is not a function. And it's pretty simple. It is, if you're looking at a graph, you want to see if something passes the vertical line test. So let me show you 2 different examples. So I'm going to show you what it looks like to pass the vertical line test, and I'm going to show you what it looks like to fail the vertical line test. So let's take a graph that looks like this. This is called the parabola. We'll do more with it in later years or later chapters. A vertical line looks like this. So if you can pass a vertical line through the graph and it only passes at 1 point, that's passing the vertical line test. It's like this vertical line would only cross the graph once. This vertical line would only cross the graph once. And what these vertical lines represent are different x values. So it's saying for this x value, I only have 1 y value. For this x value, I only have 1 y value. Now a graph that doesn't pass the vertical line test could be something like this. This fails because if you were to draw a vertical line, it would hit in 2 different points. And that means that this x value has 2 different y values. So that's why it doesn't pass. Let's look at this last example here. Average fuel efficiency for SUVs given by these values right here. Graph this information and determine whether it represents a function. Okay, so we are going to set up a little scatter plot here. So this is going to be the years, and then this is going to represent the fuel efficiency. Okay, so from 2001 to 2007. So 2001, 2, 3, 4, 5, 6, 7. Okay, so from 2001 to 2007, and then these are all the values. Okay, so the lowest is 20.6, and it looks like the highest is 22.6. So let's make this 20, make this 21, 22, and 23. So this is just going to be a little bit of practice in plotting ordered pairs. So in 2001, it was 20.8. So 20.8 would be pretty close to 21. 2002, the next one is 20.6, so close to this one, but just a little lower. The next one is back to 20.8, so this x value has the same y value as this one does. 20.9, really close, just a little bit higher. Next one is 21.6, so this is going to be almost to 22, halfway I guess. 22.3, maybe right about there, and then 22.6, maybe right there. So that is what our fuel efficiency looks like. As you can see, it's kind of going up. So let's answer a couple questions here. Graph this information to determine whether it represents a function. Well, it would pass the vertical line test. There aren't any points that are right on top of each other. So yes, it represents a function. And then is the relation discrete or continuous? Remember, continuous means you could draw the whole thing without lifting your pencil. This is discrete because it's actually just a finite set of points. So if you're literally looking at a number of points, it's discrete. If you're looking at like a smooth function like this, that would be continuous. All right, so we'll pick up with the other half in the next video.